Hey guys, welcome to my video. So it's finally time to give you the full information about the switch wire. Well, sorry, not switch wire. I'm still thinking about that, but the Voron Legacy. I'm finally done with it. I hope you guys enjoyed this video. You know, it took a while. I mean, I'm not gonna lie, it took about 2 weeks to really get this build. I mean, I know people took longer, way longer to get theirs built, but you know, when I'm honing on something, I really want to get it done. But this took me the longest. The switch wire took maybe what, a day or two. That's it. This one took 2 weeks, and that's because the Z, you know, the build volume. But I explained that in the clip coming. So I hope you guys enjoyed this video. Remember to like, subscribe, hit the notification bell. I'm trying to do one video a week, so that's my aim, one video a week. And so yeah, let me know what you guys think. Enjoy the video. Alright guys, so now we can finally talk about this build, the Voron Legacy. Where to start? I know I've gave a couple information in the last video, but now I can go in full detail on the process, you know, and everything about it. So to start, again, this was a Tronxy X5 SA. You know, your typical Chinese made quartz Y. It's not a bad stock machine if you want to, you know, buy it and use it stock. You know, I mean, you can do with a few upgrades and make it better, you know, linear rails and make that better. But in that case, for me, I really just wanted the frame, and I wanted the build volume as well. Again, the stock build volume for the Legacy is, I think, 250 by 350, or maybe 300. You have to go on the site. I should have vet that information before I started, but you know, I digress. It's around that build volume. This is oversized. Okay, this is bigger than what it's spec'd. I mean, most people wouldn't do it. Most people build Voron in spec. I'm an outside thinker. I like to take a design and blow it up. As you can see, my switch wire is blown up, and now this is blown up. So I just love the design. You know, the design is very neat, very clean, very, again, the designers did a good job of just conveying a very linear rod instead of linear rails setup, and it looks really clean. And of course, I'm not gonna cover this up or anything like that. It's just gonna print just like this, open. I really like my printers open. Now eventually I would like to build an ABS printer with it closed to print ABS, but like I said, that's further down the road. It's not in a plan at the moment, as I have other projects to work on. But eventually I would like to attempt to build a Voron 2.4, but yeah, that's going to take a lot of time, a lot of resources, and but yeah, I'm looking forward to that challenge. But back to this, the most difficult part of this build was actually the Z, and the reason for this is that in the Voron STL, there is a tool that helps you align the motor and the two rods, okay? But that's for the stock build volume. When you blow it up, I'm not really good at CAD to scale that tool, so I couldn't use it. Now, if someone scales it, that'd be freaking awesome, because then I can use it. But I have to manually realign everything, as you can see here, and it's not even perfectly aligned, because if you looked at my bed, you realize this side is further back than this side. It's just ever so slightly, as you can see. So it's still not perfectly aligned, and it's just the bed. The frame itself, the gantry itself, is perfectly squared, like perfectly squared. But it's just the bed is ever so slightly shifted that way, like kind of shifted back on one side. But that's because I'm trying to line it up. Now, there's no binding. There's no binding going up and down, because that was the issue I was having. But now the binding is clear. It's just tilted that way a little bit. Now, I'll go back and reattempt at some point when I figure out if someone if someone design a build volume like this, or try to take that tool and kind of scale it up to what I'm looking for, to my build volume. But I had to manually basically go around with a caliper, measuring caliper, to make sure each corner were measuring the same, in order to get it to level and no more binding when it goes up and down. So that's good. Now, other than that, that was the most challenging part, is just to line that up. Now, once that's lined up, the next part I had to tackle was this bed, because if you see in my previous video, I had to figure out a way. Is either I was gonna mount the bed directly to the extrusion here, because the default mounting, this thing here that comes out, that wasn't wide enough to catch the bed. As you can see, it just wasn't wide enough, and so I had to figure out a way to mount it. So initially I thought, just bolt on these two 2026 extrusion for it to sit on, and it's just kind of hard mount it down. So basically, without no adjustment, I would have just screwed it down on this, and that's it. But the aluminum, these type of aluminum, these thin aluminum, I want to say this may be what, 3mm thick, if not 4, but I think it's no, that's more 3. These things flex under heat. So when you get to like 100 degrees or close to 80, 90, it starts to like warp a little bit and flex. And the best way to counteract that is to have adjustability. So I had to think of a way to create some adjustability, and between thinking of how I wanted to do it and going on Thingiverse to find these connector, which was from I got these from these bed mounts from Thingiverse. It's originally for a hypercube, so I got the smallest version, because they come in different sizes. The designer made them in different sizes. I got the one that I think could the smallest version I wanted, because I didn't want to bring the aluminum extrusion inward too much. I wanted kind of more out. So I printed it, mounted it, level it out, measure it, make sure everything was in place, and that worked, and got springs. So now, and then I got some knobs, some small knobs, M3, and then I put the little metal piece of washer in between to kind of help me to level the bed. So now I can level the bed all the way around. So once that was figured out, I was like, whew, man, that was a headache in itself. That took me about 3 days to get all of this, the whole Z axis figured out. So your biggest challenge would be going custom. Your biggest challenge would be the Z. As long as you can get the Z aligned, measured, the bed fixed. Now you can get a fixed bed. You don't have to do what I did. You could use, you can get like a 6mm or 8mm aluminum plate, tool plate that is already flat, and then mount it directly to this. That's an option. I think that's the option that most Voron users use, is those thick, 6 to 8mm aluminum plate, and then get a silicone heater pad underneath, and that will solve the problem. But for me, I didn't want to have to outright spend more money, that would have cost me another $150, and I already have a heated bed, so I just opted to get a spring steel sheet instead, to see if that helped. And it did help. I mean, it does help. As you can see, I'm actually able to print on it. But down the road though, I would like to definitely opt for the 8mm plate that is already flat. I don't have to worry about adjustment. Mount it on here, and then off I go. but for now this is doing the job perfectly. The bed is light, so the motors don't have to work a lot just to bring the bed up or anything like that. This part here, as far as the axes, these are easy. I mean, this is like straightforward as long as you follow the CAD. I'm not sure if the manual is out by now, but I had to use the CAD to put this together. As long as you follow the CADs and have the right screws, M4, M5s, you know, M3s, as long as you have the right screw and the sizes, it's really easy to put this all together. Like this is easy. Now the next challenging part in this build is the actual belt. This belt run, like I was confused of how the belt was run, because if you can see, there's an idler here, there's an idler here, and usually the corks wide, it comes around, right? It goes around the other side. And so I'm like, how did they mount the belt? Come to find out, the belt is ran back here. So for those who want to attempt and not sure where the belt is, it actually runs back here. So it comes from here, it goes in here, comes around, goes through here. There's a little slot, if you can see the belt's running through the slot. It comes all the way back here. Then it goes into this idler, comes around the actual pulley, the motor pulley, and comes around, goes around the back, comes through this other mount motor, come around, and then comes to this side. So, and then you do that for the opposite side, of course. So yeah, this belt is insane how it runs. I had to loosen these, loosen that, shift them closer to the middle. Well, not so far, but maybe shift it closer here so I can see what I'm running the belt to. And then once you run the belt properly, I shift them back, shift this back, and that gives me some tension, bolted them up, and then tighten the belt from back here. So basically pull on the belts, make sure you have something stopping your axis, which would be your X-axis from moving backwards when you're pulling on it. That's how I did it. I mean, there's other ways to probably do it, but I kind of give it some tension already from doing that. And then the additional adjustment you can do if you need more tension is this screw here. You can screw it, and basically it pulls this part here all the way back, basically shifting the motor backwards to give you some more tension. So this belt run is pretty cool, but pretty crazy at the same time. It's very innovative. I would have never thought you could actually, you know, run the belt that way, but very slick. It just makes for a very clean build. And so yeah, so that was the most difficult part, between just tension in the belt, running the belt, make sure the tension is even on both sides, and then the the alignment of the Z, and you know, just because I'm using a bigger build area. So again, those were just the two most difficult part, but everything else regarding the printed parts, putting them together, everything was pretty easy. Now the next thing to notate is these LUM8s, I can never say them right, but LUM8 bearings, these type of bearings, I had to knock them in. They weren't that easy to go in, and if you put, you know, if you try to push it in and put too much pressure down on it instead of knocking it in, you're gonna break this part. Because like I said, I printed this in PETG, it's all in PETG, and I tried initially to, you know, kind of push it in, wiggle it in, and then put pressure down on it on like a flat surface, and it just popped. It like literally just burst this part. So I took I had to take a little holder to kind of hold this in place, and then take a flat, like a little how should I put it, like a little plate, like a flat plate, something you can rest across the bearings, and just take my hammer and knocked it in. Right, so I just took my hammer, take my time, and knock it in, and it slide right in. So that's the best way to get them in, and I had to do that for everything that had bearings. Even for these here that had bearings, I had to take my time, knock it in, and that worked. So yeah, another thing to notate is here. I'm not sure if you see that, but you see this faint line, very faint line. I'm not sure if, I think it's by design, but when you put these rods in this hole, it doesn't happen to the top, okay? The top one is spaced correctly. It's just the bottom ones that it happens to. When you put these in, this here was split open. And all 4 of them, they just split open. I think it was meant to be that way, because if you look on the opposite side, well, I'll show you right here. So if you look on this side, there's 2 screws. And basically, even though this split open down the middle, a clean split, you use these 2 screws, and basically it just tightened back up on the other side, okay? Just tighten it back up. That's why you can't really see the split clearly. So this is a pretty cool design. At first I thought I broke it, but apparently it's not broke. It seems it was by design for it to split open, and then you screw it in. You put the 2 screw in, and it connects to the heated insert, and then that tighten this back up and hold it in place. So that's how it's meant to be. So I just wanted to give you guys that info, just in case anybody wants to make a Legacy and try to put it in and it's split open. Don't freak out. It seemed like it was designed to do that. You just put the heated inserts, you put the screw in, and it comes right back together. So and it seems to hold it really tight in place, so that thing is not going anywhere. But yeah, overall it was a fun build. I did enjoy it. It was definitely the most challenging one so far, just because of the bed. I had to figure out how to get the bed working, but I did. I prevailed. Yay. It's printing good. I printed a little model here, if you guys can see, and that came out really clean at point 0.12, so 0.12 layer height, and that came out really nice and clean and well detailed. So like I said, it prints really good. I have no problem with how it prints. Had input shaper, basically resonant tuning tuned on this already on all axes, the X and the Y. Of course you don't need input shaper on the Z, since the Z just goes up and down, but on the X and Y I had the input shaper on there. So as you can see, I have my my 80XL 345. That's a little chip you need to do the input shaping. So I had that on there, had it connected, had it did its thing, and so now I can print fast. I think I was printing at like 120 millimeter, 3000 acceleration, 5000 travel. So it was pretty quick. It was moving pretty fast. So so I'm quite happy with the build. I got pretty much, yeah, I got not much to say about this. Then I'm happy it's done. Now, as far as the axes go, I want to tell you the measurement, and I had it written down if I can find it. Okay, so for those who want to build this and get the and do it now, you have the option. You can either buy a Tronxy for cheap on Amazon and gut it out and use this frame to build one, or if you can source the frame yourself, basically cut the extrusion down and mount this yourself, if you're that handy, you can do it that way. I did it the lazy way. I just got a frame, gut out the printer, basically got some extra spare parts from the printer, extra motors, extra this, and just use the frame and the bed. But if you of course the frame, it also came with the rails already. It came with 4 rails, so I just used the existing rail and cut them down to size for it to fit. But like I said, you don't have to go this route. If you're really good, you can actually source the extrusions yourself and build a frame yourself and all that. But I didn't want to have to do all of that. I just wanted something that worked, and this worked perfectly for what I was doing, and the build volume is there. So, but for the Y, if anybody want to attempt this, the Y rods are 380 millimeters. Okay, so the Y's are 380 millimeter rods. The X is 430 millimeter. As you can see, I kind of write it down on here, and the Z is 480 millimeters. Let me clear up this camera here. You guys can see that. So there you go. So that's for the axes. Okay, so if you wanted to do this or cut down some aluminum, some of these rods, linear rods, that's the size that you need. Now, you might be able to get this on Amazon, some of these sizes, But if they're not in these standard sizes, then you can cut them down. Of course, you know, you can get a cutting tool and cut them down to the correct size for them to fit. So to save you the hassle, there you go. That's the sizes for the extrusion, the linear rods. So yeah, but yeah, so I'm happy the way it turned out. So I did a little mount here to relieve the cable strain, so that way this don't get tugged on. So it's nicely tucked up in that corner, as you can see. I can show you what that looked like. So as you can see, it's nicely tucked there. So that's not going anywhere. And yeah, guys, so definitely awesome build. I love it. I would definitely try to attempt to build a 2.4, but that seems a lot more complicated, a lot more parts. It's going to take a lot more time. Eventually, I would like to convert my enders to a switch wire, but you know, that's a whole nother time. I'm being convinced to do so. But it's gonna probably be down the road at some point. I'm probably not gonna do it right now, just because I just got done building this, and that literally drained me. Like, so but I also decided to go direct drive on this one. So you could do direct drive. Now this setup is meant to be with Bowden, just so you can have a lighter tool head, since you're just using these. Because if you look, I'm going to show you. The reason why they designed this in Bowden is because of this. See this little wobble you got? That's because it's on these 8mm rods, and they're not as rigid, so you get this little rocking. Now if you're going Bowden, perfect. It's going to give you a light tool head. You don't have to really worry about a little stepper motor back here. But I wanted direct drive. I cannot go back Bowden. Like, I know Bowden has its purpose, but direct drive is so much better. It's like less retraction, you know, just, I can't explain the benefit. But you can even print fast now, because you have resonance tuning that basically tunes out the vibration. So again, there's no limitation to not go with direct drive. So I decided to go with direct drive, and I did the setup this way, so that way the motor will pull in the filament and extrude it down. So yeah, and I decided to go with the cover as well, just to kind of create that nice clean look, and that kept everything in place. So totally happy with this build. I'm ecstatic. It's been printing great. I also printed out some Voron end caps to hide the horrible aluminum cuts. I mean, it's sanded down, so it's not bad, but you know, just to hide the cuts and give it a more cleaner look. So yeah, but I'm absolutely happy. It turned out great, and if you guys have any questions, just throw it down in the comments. I'll be sure to answer. What else? Subscribe, hit the notification bell. My goal is, you know, 1 video a week, until I have the more time to kind of do multiple videos. But as you know, as the channel grows, I'll start doing a little bit more videos. Again, I'm more into the nerdy type stuff when it comes to PC, 3D printing, that type of stuff. That's what I really think about. So yeah, if you guys have any subjects you would like to talk about as well, any, you know, again, questions pertaining PCs and 3D printers, just, you know, put it down in the comment. I'll try to help you out. I try to answer all my comments, so just let me know, and I can give you some more information. So thanks for watching the video, guys. I'm glad, hopefully you enjoy it. Hopefully this was informative, it was different, and yeah, so I'll see you in the next one. Peace. Remember to subscribe, like, comment, hit the bell for notification. My goal is at least 1 video a week. That's my goal, until, you know, I can get in a routine to do more. But for right now, 1 video a week. My topics are very niche. Like, again, 3D printing, computers, you know, software, little firmwares. Like, I do those little niche things. So again, if you guys are interested into that nerdy stuff, this is the channel for you. So remember, like, subscribe, hit the notification bell, comment. Appreciate you guys. Peace.